Welcome back to part 3. In this segment, we worked with the distributive property. This is the distributive property because it is telling us we are going to multiply that 5, and we also have either it could be a subtraction problem or an addition problem. And this is the key to distributive property. You want to use these arrows to show that you have gone to both pieces of the equation or the expression. When you get farther along in algebra, you might have 3, 4, 5 pieces in this parentheses. So by taking arrows and writing each one down, I know that I've not missed any. So 5 times m. Be very careful. Do not change the order in which these are listed. This is the first term. This is the second term. They should stay first term and second term. Keep the sign, so it's a minus. And now we're going to do 5 times 2. And we're going to simplify this. I don't need the dot because, again, this is my coefficient, and it means multiply is whenever it's next to a variable. Minus, and then 5 times 2 is 10. And that is the final answer. Many students keep trying to put these together, but this is, think of this as 5 monkeys and $10. Are monkeys and money the same? No, they're very different, and that is why these two cannot be combined. They have to stay separate. So another example we could look at is 6 times the quantity 8x plus 1. Again, it's distributive property. You have multiplication and you have addition. So we're going to use our arrows to make sure that we've covered both pieces, both terms. So the first one is going to be 6 times 8x, and then we're going to have 6 times 1. And the x there is one of the reasons why we want to learn to use the dot or parentheses, because that can get confusing. Is this an x or is this multiplication? Now, when I work this out, 6 times 8 is 48x plus 6 times 1, which is 6. Again, this has a variable, this has an x. This does not have a variable, so these are different and we cannot put them together. And the last thing that is covered on the test, or in this unit, is something like this. 8y plus 9y plus 8 plus 9 plus y squared. Okay, so what I showed the kids is you want anything that is similar we're going to put together, whether you use colors to put it together, whether you use boxes, circles, triangles, whatever. So for instance, this says 8 yellows. It's actually 8 Ys, but we use blocks in here for the past couple days to show this, to model it. Plus, let's say this is 9 yellows. These two are identical. You could think of it as blocks. 8 blocks that are yellow, 9 blocks that are yellow. Okay? We would not hesitate to add 8 blocks that are yellow plus 9 blocks that are yellow. When we do that, 8 plus 9 is 17y. This just says I have 8 yellow blocks plus 9 yellow blocks, so I have 17 yellow blocks. Okay? And then I have these numbers that are the same. So I'm going to go ahead and circle this 8 and circle this 9. I have, let's say, $8 plus I have $9. When I put this together, $8 plus $9 is again $17. Okay. And then we have this piece out here on the end, this y squared. Now, even though this is a y, I like to explain it as if you had an apple, this is an apple pie. While it's similar, it has a lot more ingredients in it. So this while it does have a y, is not the same. This is y squared. So we're going to keep the y squared separate. Now, there is plus signs in between each of these, so I'm going to fill that in. And another part that I'm not stressing yet, we'll get there eventually, but you always write it from the variable with the biggest exponent first, and then you work your way down. So really this would be y squared plus 17y plus 17. But I'm not worried about that at this moment. So those are all the different things we took a look at in this unit. The algebra is new, but the rest of it had been covered slightly in previous grades. Now, one of the things that our students are struggling with are word problems. And so I want to look at just a few of those. We're going to look at this one. Peanuts are sold in 8 ounces and 12-ounce packages. What is the fewest number of ounces you can buy of each package to have an equal number? So the important thing here is we're looking at 8 and 12. We want them to have an equal amount, but we have not purchased them yet. What I like to tell the kids, it's like we're balancing 8 and 12, and when do they finally come to an agreement? This would be similar to our common denominator. So what that means is we're finding our least common multiple to answer this question. So first we're going to start with our trees. 2 times 4 is 8, and then 2 times 2. So this is our tree. Our prime factorization of 8 would be this. We just summarize. 12, we could say 2 times 6, or I'm going to use 3 times 4. And that gives me these leaves. So 2 times 2 times 3, because I found all the prime factors of that number. Now, to find your least common multiple, what you're going to do is everybody goes to the party. So we have to have a 2, and we're going to have a 3 because they're all going to the party. Now, we go back and say, now who has the greatest number of them? So we have 3 2s, or if we have 2 2s, what is the greatest number of them? Well, the greatest number is on this side. So we're going to say 2 cubed. What is the greatest number of 3s that could come? Well, that's 1. Okay, so we don't need to write it as it's understood. We do need to evaluate this. So 2 cubed is 8 times the 3, so 24. So what this tells us in context of our word problem is that we need 24 ounces. Okay, now you have to be careful because while we need 24 ounces, we have not actually solved this problem yet. What we need to do is now say, well, if I have 24 ounces and it's sold in 8-ounce packages, how many do I need? Well, I need 3 packs of the 8-ounce ones. And if I take the 24 ounces and I divide it by 12, I'm going to need 2 packs of the 24-ounce peanuts. Okay? So that has been difficult for the kids, but most of them are understanding that if it's equal groups and it has not been bought yet, you're going to do the least common multiple. This one, and it does tell you, this one says the garden is 18 feet long and 30 feet wide. He wants to put a fence post the same distance apart along all sides of the garden. So in this case, we already have 18 is given. It can't change. We're not buying anything. We already have 30. It's given. From there, we are going to put fence posts along the sides of the garden. We want the greatest distance, and the distance must be along the same all the way around. Okay, so we're going to break this into equal numbers. So we need to know how many we can, what's the distance he's going to put these at. That is going to be your greatest common factor. So when you find your factors of 18, again, you can do whatever. 2 times 9 would work, and then 3 times 3, okay? And then 30 is 3 and 10, and then 2 and 5. So what we want to look at for the greatest common factor is, what do they agree on? Well, they both agree on a 2. So we're going to use that. They also both agree on a 3. So what is common is the 2 and 3 in both of these, which gives us a greatest common factor of 6. So the distance is going to be spaced 6 feet apart all the way around, and that way we will be able to use the 18 feet and the 30 feet, and we'll be able to cover all the way around this garden. So greatest common factor, the numbers are always set. You're not buying anymore, and you have to have an equal distance. All right, some other word problems that students have been struggling with. This was on, this one I don't believe all of our students have gotten, so I'll go ahead and use this example. At a drive-through restaurant, Casey's family ordered a small drink and an M medium drinks. Anika's family ordered M medium drinks and a large drink. Write an algebraic expression that shows the total cost in dollars of both orders. So we're given this information about the drinks, how much they cost. Casey's family ordered a small drink, so she just ordered one small. So we know that price is $1.10. It can't change because we already bought it. Now, she is also buying M medium drinks. So we don't know how many medium, just M, it's an unknown, but we know the medium costs $1.25. This is what Casey's family is buying. But we're going to also put in another order for Anika's family. She ordered M medium drinks, so the medium drink is $1.25. And she bought M of those. It's unknown. We don't know how many medium drinks she's going to be buying, and that's why we're leaving it as just a variable. She also bought a large drink, so that means just one large drink. And when we look over here, the price is $1.50. So this is how much Anika's family ordered. That would be the expression. Now, the second part of the problem asks you to combine like terms. So when we do that, again, that's thinking what is the same, and we can combine those. For instance, here's the $1.10, just money, and here's $1.50, just money. So we can put those two together, $1.10 plus the $1.50. When I add those together, I get $2.60. But we still have more here. We have these medium drinks. So now I have this medium drink, $1.25 M, and I have another one of those, plus $1.25 M. So $1 plus $1 is $2, 25 cents plus 25 cents is 50 cents M. And I'm going to not lose the fact that these are added together. And that's all we do. Now, we could take this one step farther. You might be told then that M equals 3. So now what we can do is we can evaluate this expression using M as 3. What that means is our $2.60 remains, and we're going to have $2.50 times our value of M, which we're going to use as 3. Let's go ahead and use this as parentheses. So we're going to work this first. So when we work $2.50 times $3, that is $7.50, plus this $2.60 that didn't change. And when we add these together, we get $10.10. So we're able to combine quite a few of those operations to solve this problem. All right, and then we had one other set of word problems that some students had questions on, and we were not able to answer those in class. So I'm going to go ahead and do that here. This was page 150, and we're going to look at number 29 and just set it up. So you probably won't be able to see this because it's so small. But your student has it. It is page 150, number 29. This says Tamara is making a medium length necklace. Write an expression that shows how much it will cost Tamara for the chain. Okay, so when we look over here, we need a chain and it needs to be medium, which means we're going to use this $1.80. But when you make a necklace, you only need one chain. So we're just going to have $1.80 because there's just one chain. There we go. Next, we need a pendant. Well, chances are there's only going to be one pendant, and we were making a medium necklace, so that means it's $3.72. And then they're going to put beads on this. The beads are 25 cents each, but we have the unknown B. We don't know how many beads we're going to put on here, so we're going to keep those 25 cents times B so that we can put however many beads we want on our necklace. So that would be the exam. That would be how you set up the expression. And then it goes on to tell you they want you to find the total cost of the necklace if she uses 30 beads. So that what that means is we're going to keep the $1.80, keep the $3.72, and we're now having 25 cents times 30 because that's how many beads we wanted to put in. Okay, so when we solve that, we need to work this first. Okay, and so let's see here, 25 cents. We're going to multiply by 3, which we know is 75 cents, or 75, I should say. And then we can go ahead and add that 0 on at the end. The students know when they do decimal multiplication, they should be using the wall. There are 2 decimal spots here. There are no decimal spots here. So that means in our answer, we must have 2 decimal spots. So we move in once, twice from the wall. So that means this amount is that $7.50 plus $3.72 plus $1.80. And then we're going to add these together. And when you add those together, I guess I'm going to have to work it out because I don't have it here. Oh, yes, there it is. It'll be $13.02. Okay. And that will help your student through everything in topic 3. And there are study guides loaded in the Google Classroom. There are actually 2 of them with the answer key.